All right, this should be a fairly short lecture, mostly because I expect a lot of this to be reviews. So the water cycle is something that you have seen. I know it's in your grade school curricula. I know it makes its way back into any sort of life science you had to take in high school. And so I'm just going to go pretty quickly through some things that should be familiar and point out a few things that might be new. Again, all of this relating to a little bit more in-depth water cycle reading that you had to go with us for today. Maybe you're going to notice a few slides that go with this, or a few diagrams that go with this. So here are some the goal of the lecture and some objectives for you to be able to think about. Can you do this? So let's start with the water cycle. Hopefully, you've seen something like this before in your education. This is a basic water cycle that, again, makes its way into grade school curricula. What you're seeing here, again, is your classic precipitation, right? So water falls to the earth in the form of precipitation. Some is going to go ahead and infiltrate and become part of groundwater that's moving below the surface of the earth. And we do use this groundwater for quite a bit of our water purposes that meet human needs. And then some of it is going to actually go on the surface of the earth and go into our streams and then subsequently lakes, and ultimately ending up, well, not necessarily always in that order, but ending up in our oceans as well. From all of these surfaces, we're going to have evaporation happening directly off of the surface of water. And then transpiration, which is the evaporation that's coming out of leaves. So you might recall that plants need water to photosynthesize, and the back of leaves have these little openings in them that we call stomata. And those actually have water. They're continually sort of losing water out of leaves in this process of transpiration. That's part of the way they actually pull up new water molecules through the roots. So this process of evaporation and transpiration that puts water into the atmosphere, which then condenses, condensation, and then falls to the earth in the form of precipitation. So this is our classic water cycle. A few important things to notice. This is a closed loop. What that means is there is a kind of finite quantity of water that exists on the planet that's going to be circling between between lakes, streams, oceans, plant life, and our atmosphere, and then our groundwater. So those are all the places really water can be. This is a little bit more technical. It's just showing you generally what we expect in terms of the amount of water that's moving through this cycle at any given point. An important thing to keep in mind, this is going to come up a bit during climate change. I'm just going to point it out now, that water has about an 8 to 9 day residence time in the air. So when water evaporates, it can only stay in the air for a certain amount of time before it naturally is going to start to condensate and clump onto other water molecules and fall back down to the earth in precipitation. And it's important to understand this because one of the things we're seeing with climate change is increased heat and therefore increased evaporation. The heat in the atmosphere is actually causing the atmosphere to be able to hold more water at any given time. And then it has to kind of all come down at once, and it dumps onto the earth in a more violent fashion, which is one of the reasons, there are multiple reasons for this, but it is one of the reasons that we're seeing more intense rainfall and storms with warming climates. So this is our groundwater, or this is our global water cycle, a little bit more technical probably than what you saw in your K through 12 education. And so here we're going to move to this idea of water stocks. Water stocks is where water is located at any given time that may be available for human use. And this is where we're getting into, again, this is our freshwater boundaries. So we're now on a different boundary of the planetary boundaries model. And what we're trying to understand ultimately is how much water is available for human use and human consumption, and what are the impacts that we're having on this planetary boundary system. So if I just told you in the last slide that this is a closed loop or a closed system, it would in theory be impossible to run out of water. But of course we know that's not actually what's happening. So let's talk about why there's some potential problems with our ability to use unlimited amounts of water. First of all, we have 97% of the water on the planet is going to be held in salt water, and the remaining 2.5% is fresh water. Of that fresh water, the vast majority is in glaciers and permanent snow cover, right? So we don't actually have access to that. So we're looking at about 69, 70% there. And then the rest of it we're going to be able to find in fresh groundwater and then freshwater lakes, wetlands, rivers, streams, etc. And then a small amount is actually going to be in soil moisture and those places. So this is our general distribution of water on the planet. So you'll note what we actually have available to use is this small percentage of this total. And to give you a little bit more clear numbers, right, so rather than, this is now broken into a true percentage out of 100, you can see that what we're talking about is this, right? So it's, we're looking at, I'm adding this up quickly in my head, but less than 1% of water is available for human use of all the water on the globe. So this is one reason for a limited supply of water, why there is actually a limit to how much there is compared to human needs. Another reason has to do with our uses of water. So what are we using water for on this planet? This comes from a Nature article. Down here you can see the citation. So this is where we're using water, and this is what we're using water for. So this is our total water consumption. You can see that at a global level, the majority of it's going to agriculture. And then here is where different places on the globe are using a lot of water. Okay, and then again here we're able to see, you know, who's using what kind of water, right? So across the world, again, most of it going to agriculture, and that trend will hold, but you notice it's actually not the trend in North America and Europe, where industry is slightly surpassing agriculture. So producing goods through something that we're going to call virtual water. So water is used to produce goods that we buy. And so when you do a water footprint quiz in the coming activities, you will see that you're going to talk about something called virtual water, which is this water you're using through things that you're consuming. So what this ultimately comes out to as we raise the population, so this is going to be a similar to what we talked about with material consumption. So as the population grows, and we have people actually potentially using more water intensive resources than in the past, we're going to potentially have a decreased water availability per person. So this is just looking at global, total global issues. And if you notice, the planetary boundaries, we're still within the safe zone of the freshwater boundary. So we're not actually surpassing the demand per capita yet. All right, so here is the potential challenge. I would imagine you're all familiar with the issue of water scarcity and water shortage. Depending on where you're from, it may or may not have actually been a pressing issue at any point in your life. If you are from the Southwest of the United States or the West Coast even, particularly California, you are probably familiar with this. I remember many, many years ago, I grew up in the Midwestern region of the country, and I remember visiting a relative out in California and being surprised by all the things, the water saving measures that they had in place that I had not yet seen in the Midwest. And so depending on the region that you're in, you're gonna have more or less of a water shortage or water scarcity problem. And then of course, this is amplified across the globe. I think you're all probably had heard at some point of Cape Town, South Africa, and the dire water crisis that they had been facing. To be completely honest, I haven't looked it up in the very, very recent past, but I know that last year this was, they were counting down to when they were going to run out of water. And they did manage to avert some of the crisis, but I'm willing to bet that it's still there on a certain, in some communities being severely impacted. Okay, so the reason for this is this. Water does not precipitate equally across the planet. Populations are not equal across the planet, and water consumption is not equal across sectors of society. And so this is what we mean by, if I ever say the term water is a scalar problem, that it's a closed system ultimately. There's water on the planet. We are a watery planet. But depending on where you are on the planet, you may or may not actually have access to enough water to meet everybody's needs. And this becomes further complicated by the issue of water pollution. There are many places all across the planet where people do not have access to clean water. So a place that made very big headlines in the United States, although there are other places that have not made the headlines within this country, but was Flint, Michigan. Flint, Michigan being a place where they, due to some decisions made at the government level, the water that people had access to was being contaminated with lead. And so again, there was water there, but they couldn't get access to clean water for the local population. And then of course, if you have followed the story at all, the government did not tell the people about this and instead allowed people to drink contaminated water for a long period of time, which lead is a strong pollutant and particularly dangerous for children. And so looking again here, this is just continental water availability, right? And water availability per capita. So if you're looking, and again, this is continents, so super coarse measurement. I think you all probably know it wouldn't be terribly easy to get water from, let's say, the Blue Ridge Mountains, which is our kind of watershed, over to California if they needed it, right? So a continental scale is not terribly insightful, but this is a good general idea, which is how much water falls per year and then how much is available per person. And in some readings, you're going to look at indicators of water stress, right? And so all of this is plenty of water per person in this North America. But you notice as you move over into Asia, that there's a lot of water falling, but there's also a lot of people there. So here we're getting closer to water stress levels. And so again, here's just availability by subregion. So giving us a little bit more of an idea of what kind of thing we're looking at. And then you can see through these color coding here, areas of the globe, such as Northern Africa, where we have catastrophically low amounts of water, right? And then here in the Arabian Peninsula, as you're moving over into India, you're seeing, low levels of water, but not the catastrophically low, right? But then as we know, Cape Town, South Africa over here, we know it was having a crisis, and yet at this scale, you're not going to see that crisis to the same extent. So water availability, it's a scalar issue. It has to do with local demand and local waterfall patterns and reservoirs. Okay, water use impacts. To further complicate the matter, I already spoke a little bit about pollution, and I have a separate lecture talking about pollution. But just a few general things here, a little bit of an overview. First of all, our water use draws water out of other reservoirs, and that can make it so that aquatic life doesn't have enough water for their needs. Here's the Aral Sea example that I've talked about already, but this is an example of water being diverted from the Aral Sea to meet the demands of agriculture in the nearby region and actually drying up the sea. And then here's an image I mentioned before that the Colorado River does not run all the way into the ocean. And so it actually runs completely out of water now, dramatically changing this entire ecosystem in this area. Here's projected global water scarcity. This is only 5 years from now. You may or may not be familiar with a lot of politicians and climate scientists have been estimating that water is going to be one of our biggest concerns in the future, in part due to potential climate change patterns that we're already beginning to face that's changing the way that water flows on the globe and that we've come to depend on. So here's just a general projected estimate of what our global water scarcity could look like in the future. So here's some questions. There's a discussion forum that hits on some of these too, but some kind of food for thought, if you will, about what are some of the challenges with water and how might we approach this in the future.